So here's where we left off. We were talking about different types of functional interfaces last time. We talked about predicate. We talked about function. We talked about bifunction. We talked about supplier. Now we're going to talk about consumer. And as we'll see, the consumer is kind of the dual of supplier. So supplier will create stuff and consumers will consume it. Surprise, surprise. So a consumer accepts a parameter and returns no result. Just like a supplier will generate a result and not accept any input unless you use effectively final variables with lambda expressions. Consumer is parameterized by type T, nothing surprising there, and it has a single method called accept that is passed this parameter of type T and returns nothing. Let's take a simple look at an example to illustrate how consumers can be used. This is a variant of what we looked at before. Actually, it's the same thing we looked at before. We're just going to focus on a different part of it. This is the example where we create a list of threads, where we give the threads the names of the Three Stooges. And this time, rather than focusing on the sorting part, we're going to focus instead on the part that's going to print out the elements that are in that list. So we're going to look at the for each method. So you can see threads.forEach. That's the for each method defined on iterable. And what it'll do is it'll iterate through every element in the list and call println on each one. This is what the for each method looks like. As you can see, it's defined as part of the core classes and interfaces that are part of the Java development kit or the Java class library. It takes a consumer, which is called action, and in this case, we're going to bind that parameter to the system.out::println method reference. So that method reference is what gets bound to the consumer, because if you think about what this is going to do, this println method takes a parameter and returns no value. So it matches what consumer does. Takes a parameter, it returns no value. So its function descriptor matches the signature of that method. We then are going to go ahead and iterate through every element in the collection that we're working with here that has implemented iterable using a for each loop. And for each element in that collection, we're going to go ahead and accept the element into the action. So that's kind of a way of sort of getting the result to do something. In this case, that will turn out effectively to be something akin to system.out.println T, where T is the parameter that's passed in here. So pretty cool, pretty straightforward. Consumers are fairly straightforward. And you'll see some interesting examples when we get a little further in the course when we talk about some of the Java 8 streams framework components, like splitterators, which will use consumers to do various interesting things. Yeah? What would happen? So are you asking this in the context of functional interfaces? Yeah. Sure. So keep in mind that, well, let's see. So there's two different parts to your question, I think. Or let me see if I can restate your question. So there's a question, what if I had something where I had, let's see, a list of thread, and I had a list of employee record or something like that. Is that the question that you're asking? Or are you asking, what if there are two methods, one accept that took one type, one accept that took another? So again, let me just make sure I understand the question. Remember, functional interfaces only have a single abstract method in them. So there would be no overloading. So that issue would never occur. Does that answer your question? OK, good. Yeah, so that's the thing to remember, that functional interfaces work because they have a single abstract method. And I'll give you a little caveat to that in a second. But effectively, think of them as having a single abstract method. And that way, I think your real question is, wouldn't there be ambiguity if there were multiple methods? So that issue is sidestepped by the rule that you only have a single abstract method in a functional interface. If you don't have a single abstract method, it's not considered a functional interface, and therefore couldn't be used as the basis for a lambda expression or a method reference. Now, there's going to be one interesting caveat to that we'll talk about in a second, but that's the best way to think about it for now. So now that we've talked about these core interfaces that are used quite widely, let's talk about some other properties of functional interfaces. And this will be kind of an interesting follow-on to the discussion we just had, because you see that there is one kind of ironic exception to the rule that you only have a single abstract method in a functional interface. So functional interfaces can have multiple methods. It's just that they can only have one abstract method. And so that would be the one that would be relevant for the purposes of a lambda expression or a method reference and so on and so forth. So here's an example of an interface that comes right out of the box with Java. It's called the comparator interface. We've seen that before. We talked about that when we were talking about the sort algorithm that would be used on the list of threads. And so comparator is a way of being able to impose a total ordering on some collection of objects, like the list of threads. Now, there's a couple of interesting things here. So first of all, you'll see that comparator is a functional interface, and you can actually designate it as such using the annotation syntax in Java. So comparator is a functional interface, and you can make that specific designation, just like you can say @override as an example. There's other annotations you can have. You don't have to have this, but if you mark an interface as being functional, then the compiler will check to make sure it really matches the properties of a functional interface, namely having one abstract method. As you can see here, in this particular interface, the compare method is the primary abstract method in this functional interface. So that's the one that's going to be used in the ways that we saw before in the context of those other examples. There are other methods here, however. For example, there's a method called reversed, and this is a default method. So it's an interface method that's not abstract because it has an implementation. And you can override the implementation if you so choose. But if you don't override it, what it'll do is it'll basically reverse the comparison. So it'll look through the comparison, but it'll reverse it. So instead of doing ascending, it'll do descending and vice versa. There's also another method called reverse order. Notice it's not an overloaded method, but it's a method called reverse order that happens to be defined as static. And the difference between a default method and a static method is the default method has a default implementation that can be overridden. So you can come along and customize reversed if you so choose. Conversely, a static method has the one and only implementation that's defined here. So that's the difference between default and static. A minor point, but one that's worth at least keeping in the back of your mind. Now, here's where things get really interesting. So it turns out that the comparator interface has two abstract methods in it. One of them being the compare method we talked about before, and one of them being the equals method. Now, what the heck is going on here? Before I told you that a functional interface could have one and only one abstract method, but now we've got two abstract methods. What's going on? Well, it turns out that there's a special case rule that goes back to your question from before, which is that if an interface overrides a public method defined in the java.lang.Object super duper class, right? Remember that every class in Java extends java.lang.Object whether you explicitly designate it to extend it or not, right? It's the root of all classes in Java, implicitly. If you override a public method from that class, that doesn't count as part of the interface's abstract method count. So that's pretty freaking crazy, but that's the way it works. So they kind of have this special case for java.lang.Object. In retrospect, java.lang.Object was probably something that could have been handled in a better way. I think if they had a chance to do it all over again, they probably would have made java.lang.Object an interface with default methods or something like that. But be it as it may, it's got this special purpose in Java. So that's a little bit weird, but that's just the way things work. Okay, so that's essentially the end of our discussion related to functional interfaces. So hopefully you now have the basis for the programming that we're going to be doing henceforth, which will use a lot of these functional interfaces in various ways.